I wanted to do a video on RC circuits. Even though we talked about it in class, it's been a while, and it will appear on the third midterm and possibly on the final exam. So RC circuits, basically the idea is, the analogy is you have a cup, kind of like a cup of water. That's like your capacitor. And the cup of water has a hole in it. And that hole in it is kind of like your resistor. And out of the cup of water, through the hole, pours out the water. So the bigger the hole, the smaller the resistor. So a small hole means a big resistor. Alright, so that's just conceptually what it's going on. More specifically, if you were to actually have an RC circuit where this is happening, you could think about it like this. You can think about it as a battery hooked up to a capacitor. And whoops, resistor also in the circuit. And I'm going to say that there's a switch here. So excuse me, at the moment the switch is closed and the battery is hooked up into the circuit. Battery is a voltage V. The same voltage V, by the way, is going to appear across the capacitor and across the resistor. Alright? And when that voltage appears across the capacitor, of course it leaves charges on the capacitor. Plus on one side and minus on the other. Okay? So my capacitor. Okay, so I have minus on the bottom here. These are my minuses, and these are my pluses. And then when the battery is taken out of the circuit, which can be done simply by opening the switch, now the battery is no longer part of the circuit. The circuit just consists of the capacitor that has this charge on it and the resistor. So the circuit, after the switch is open, is effectively just this. And there's some plus charges here and some minus charges here. And so what's going to happen then is that these plus charges are going to go down across the resistor as a current. They're going to meet up with the minus charges and cancel each other out. But that's going to take some time, and at first there's going to be this big unrush of plus charges as they all try to escape. But as time marches on, there's going to be fewer and fewer of them there, so there'll be a decrease in the number of positive charges going through the resistor. So that's just the conceptual notion. Quantitatively, I derived this in class that, I won't rederive it right now, but just state the result, that the voltage across the capacitor as a function of time is equal to its initial source voltage, which is the battery voltage, times e to the minus t over RC. We derived that in class. Like I said, I'm not going to derive it right now. But I do want to explain it. Basically, at time 0, you could say that the initial voltage across the capacitor is just the source voltage across the battery, which makes sense. That's what it was right before we opened the switch. It was going to be equal to that. Or if you put a 0 in here, into t, e to the 0 is just 1. So your initial capacitor voltage is just the source voltage. Now as time marches on, you're going to see that your capacitor voltage, which started at source voltage, decreases exponentially. So this is voltage across the capacitor as a function of time. This is time, and this is the source voltage right there, the battery voltage. Now, a time of interest is when the time is equal to the product of the resistance times the capacitance. Then the voltage across the capacitor is, if you put this value in up here, you'd find out that the voltage across the capacitor is equal to e to the minus 1 times the source voltage. E to the minus 1 is about 39%. So at one time constant, you're at about 0.39 Vs when t is equal to Rc. And then that keeps happening. So the next time constant, it's 39% of 39%, etc. So it goes down quite quickly. Well, that's the nature of the exponential function. So if you put numbers in, as we talked about in class, for the resistance and the capacitance, you can figure out how long it's going to take your voltage to drop down to 39% of its initial value. And that is known as one-time constant. And remember, R times C also has units of seconds, as we talked about in class. All right, that's it for now.